During the autumn of 1942, top metals experts at the BMW weapons plant in Munich examined a captured American military motorcycle with growing disbelief. German troops had pulled the machine from the burning sands of North Africa. The vehicle was a Harley-Davidson WLA model, built on the assembly lines of Milwaukee. Expecting crude factory work and loose tolerances from fast American mass production, the German engineers stripped the engine block down to its bare iron bones. What they found inside surprised everyone in the workshop, a mechanical anomaly that defied their calculations. The heavy cast-iron crankcase held tight oil seals without using a single rubber gasket, operating under violent cross-country vibration that should have sheared the main bearings in half. Even stranger was a secret heat-treating stamp on the connecting rods. A metallurgical footprint German industrial intelligence had spent 5 years trying to steal from a Milwaukee machine shop. For months, Allied dispatch riders had been plunging these machines through sub-zero mud and desert heat, while European engines seized around them. The secret was not high-tech German alloy science, nor was it a multi-million-dollar War Department contract. It was a single, stubborn manufacturing principle engineered decades earlier inside a tiny, wooden shed by two blue-collar boys who refused to let iron fail. You are watching Rivet and Rebar, where we dig into industrial giants and mechanical sagas that quietly built the modern world. If forgotten industrial history and precision engineering are your thing, take a moment to like and subscribe to support long-form documentary history. Now, back to where it all began. At the turn of the 20th century, Milwaukee, Wisconsin was a city forged in fire, coal smoke, and heavy industry. Blast furnaces along the Menomonee River glowed crimson into the night, casting long shadows across dirt roads where horse-drawn wagons hauled pig iron through winter slush. It was an era of unyielding physical labor, where men measured their worth by calluses on their palms and the precision of hand files. Inside this pressure cooker environment, 21-year-old draftsman William Harley spent evenings hunched over a wooden drawing board. Harley entered the workforce at 14 as a floor sweeper in a bicycle factory, learning shop life from the bottom up. Yet he possessed a rare dual intellect, raw instincts of a floor mechanic paired with a mathematical mind that carried him through engineering studies at the University of Wisconsin. Joining him was childhood friend Arthur Davidson, an apprentice pattern maker at Barth Manufacturing Company. Arthur understood wood and sand, carving patterns with precise shrink allowances needed to cast molten iron without distortion. In 1903, in the backyard of the Davidson home, Arthur's brother built a wooden shed measuring 10 by 15 feet. Scrawled across the pine door in crude red paint were 4 words: Harley-Davidson Motor Company. Picture running a foundry inside a space smaller than a single-car garage. They had no electricity or precision grinding machinery. Primary tools were a foot-cranked lathe, a bench vise, and hand scrapers. Winter cold whistled through pine boards, freezing cutting oils, while summer heat turned the shed into a suffocating oven. Yet inside this shed, Harley and Davidson set out to build something far more durable than a motorized bicycle. Early pioneers clamped light gasoline motors onto flimsy bicycle frames. These machines were notoriously fragile. Frames buckled under torque, leather belts slipped in rain, and iron cylinders cracked on dirt roads. Harley and Davidson realized early that a motorcycle could not be an oversized toy. It had to be heavy industrial machinery, built to the same rugged standards as a steam locomotive. They brought in Arthur's brother, Walter Davidson, a skilled machinist working for the railroad. Walter brought heavy rail manufacturing discipline into the shed. The work was painstaking. They hand-fitted every bushing, lapped valve seats with abrasive paste, and poured Babbitt bearings over open flames using simple hand tools. Raw iron demanded perfection. Another major obstacle facing early motorcycle builders was a frustrating mechanical bottleneck. structural flexing, and engine self-destruction. The first prototype Harley and Davidson completed in 1903 used a tiny 116 cubic centimeter engine. Tested on Milwaukee hills, it failed to climb modest inclines without the rider frantically pedaling to assist. The engine lacked volumetric efficiency and structural rigidity to survive continuous load. This bottleneck stemmed from early metallurgy and frame geometry. Single-cylinder engines of the era suffered from severe cylinder wall distortion. As cast iron heated up, uneven wall thickness caused the cylinder bore to expand out of round. Piston rings lost their seal, compression blew past the crankcase, and oil spewed from every seam. Single-loop bicycle-style frames twisted under torque, throwing drive belts out of alignment. Harley redesigned the machine from the crankcase up. To solve the bottleneck, he increased engine displacement to 405 cubic centimeters, casting a heavy-walled gray iron cylinder with thick cooling fins designed to distribute thermal stress evenly. To eliminate flexing, Harley developed a double-loop steel tubing frame that cradle-mounted the engine, isolating the crankcase from chassis twist. Think about what that means in an era before automated CNC machinery. Every casting was poured, stress-relieved, and machined by hand. To achieve a proper seal between piston rings and cylinder wall, Walter Davidson spent hours lapping the bore with fine abrasive compound, achieving tolerances thinner than a human hair, less than 1/30th the thickness of printer paper. Next came the oiling system. Early engines relied on crude splash lubrication, where the rider manually operated a hand pump every few miles. Forget to pump, and the engine welded its piston to the cylinder wall. Overpump and the spark plug fouled with soot. Harley designed an internal flywheel counterweight system with integrated oil channels, sloshing oil directly onto the connecting rod journal and cylinder walls with every revolution. In 1909, Harley introduced the 45-degree V-twin engine. Mounting a second cylinder on the same crankcase at a 45-degree angle, Harley doubled displacement to 810 cubic centimeters while utilizing a single crankpin shared by both connecting rods. This layout created the iconic, uneven firing order and rhythmic thrum that defined the brand for over a century. But early V-twins faced another bottleneck. Automatic atmospheric intake valves pulled open solely by cylinder vacuum, causing misfires at high speeds. In 1911, Harley solved this by developing a mechanically driven intake-over exhaust valve system, operated by hardened pushrods and overhead rocker arms. The result was a mechanical revelation. The machine did not merely run, it endured. While competitors sold delicate novelties through middlemen, Harley-Davidson disrupted industry norms through transparent engineering. They published upfront parts catalogs with standardized pricing, established factory-trained mechanics, and introduced vertical integration. They poured gray iron castings, forged steel triple trees, and heat-treated transmission gears right in Milwaukee. When local police tested silent gray fellow models against rival bikes, results were decisive. Where other motorcycles broke spokes and burnt clutches, Harley-Davidson machines ran continuously for 24 hours without failure. They held the line. The ultimate stress test for any mechanical creation is not found on a smooth testing track. It is found in the brutal cauldron of war. In April 1917, as the United States entered World War I, the U.S. Army urgently needed a rugged reconnaissance platform capable of navigating knee-deep mud and shell-cratered terrain on the Western Front. Harley-Davidson answered the call, dedicating over half of its factory output to the war effort. More than 20,000 Harley-Davidson motorcycles shipped across the Atlantic to France. Dispatch riders operated under nightmarish conditions, carrying tactical messages across battlefields where artillery fire destroyed telephone lines. The iron was pushed far beyond theoretical limits. Riding through torrential rain and thick European clay, These machines carried heavy military loads, mounted machine guns, and ran on low-grade fuel contaminated with dirt and water. Yet rugged steel frames, enclosed chain drives, and heavy-duty V-twin engines kept moving forward. When Allied forces breached German lines in November 1918, the very first American soldier to enter occupied German territory, Sergeant Roy Holtz, was riding a Harley-Davidson motorcycle. The company emerged from the war as the largest motorcycle manufacturer on Earth, occupying a massive complex spanning 500,000 square feet on Juneau Avenue. Then came the Great Depression. Economic collapse in 1929 decimated the American motorcycle industry. Over 200 motorcycle manufacturers filed for bankruptcy or vanished into obscurity. Sales plummeted from tens of thousands of units a year to a tiny trickle. Harley-Davidson survived through manufacturing versatility and financial discipline. Refusing to compromise on material quality, the company diversified into building three-wheeled delivery vehicles known as the Serv Car, industrial power units, police vehicles, and custom fabrications. They weathered the storm as one of only two American motorcycle companies to survive intact. Hold that thought, because a second global conflict was about to push the Milwaukee factory into overdrive. During World War II, Harley-Davidson produced more than 90,000 WL military motorcycles. Workers worked round-the-clock shifts, machining heavy forged steel crankshafts, hand-scraping fixtures, and assembling bulletproof flathead engines. The U.S. military awarded Harley-Davidson the Army-Navy Award for Excellence in War Production. The machines survived the Blitzkrieg. This brings us back to the mysterious anomaly that baffled German metallurgists at the BMW plant in Munich in 1942. When Nazi engineers disassembled that captured Harley-Davidson WLA, they were desperately searching for the secret behind its legendary field reliability. Why did these American engines continue running long after European units seized from dust, heat, and oil starvation? The secret lay in a classified heat-treating process and tolerance philosophy that Harley-Davidson perfected right on the Juneau Avenue factory floor. During the late 1930s, William Harley realized traditional rubber and paper gaskets could not survive the intense thermal expansion and continuous high-frequency vibration of heavy military use. Gaskets dried out, cracked, and blew out, causing catastrophic crankcase oil loss in the field. Harley's solution was brilliant in its mechanical simplicity. Instead of relying on soft gaskets to stop leaks, he insisted on absolute surface flatness between mating engine components. Crankcase halves were cast from specialized high-density gray iron alloy and stress-relieved in giant coal-fired kilns. Workers finished the faces on heavy iron lapping plates using microscopic abrasive powders. When bolted together, the metal fit was so flat that oil molecules could not pass between joined faces. Furthermore, the intelligence puzzle regarding connecting rods came down to an induction hardening method developed by Harley's lead metallurgists. Connecting rod bearing races were heat-treated using an alternating current electric field. This hardened the inner wearing surface to file hardness, while leaving the inner core of the nickel steel rod tough and ductile. German metallurgists, accustomed to uniform heat treating that made metal soft or brittle, could not replicate the dual-grain structure without exact electric frequencies and oil-quench bath temperatures developed in Milwaukee. When German spies tried to acquire process specs before the war, Harley's shop foremen intentionally altered heat charts on the shop floor to misdirect foreign observers. Captured WLA engines weren't surviving on high-tech exotic metals. They survived because William Harley and his master machinists designed every component to carry a structural safety margin that bordered on obsession. They engineered iron to withstand human abuse, extreme weather, and mechanical neglect. The mystery was solved. The iron had spoken. For decades following the war, Harley-Davidson stood as monarch of the American road. But as original founders passed away, William Harley dying in 1943 and Arthur Davidson in 1950, the soul of the company drifted away from the shop floor into the hands of corporate bean counters. By the late 1960s, the company faced financial strain. In 1969, seeking capital, Harley-Davidson merged with American Machine and Foundry, a conglomerate known as AMF. AMF made bowling equipment and leisure boats. It was a marriage made in corporate hell. AMF executives brought a spreadsheet mentality to a factory built on hand-scraped craftsmanship. Corporate leadership slashed headcounts, sped up assembly lines, and stripped away quality control checks. Raw castings were machined on worn tooling, paint standards plummeted, and engines were rushed off the line with improper torque. Brand new motorcycles arrived at dealerships leaking oil directly onto showroom floors, prompting bitter jokes that Harley riders had to buy two bikes, one to ride and one for spare parts. Morale on the Juneau Avenue shop floor sank as skilled machinists watched management prioritize volume over mechanical excellence. To make matters worse, a foreign invasion hit American shores. During the 1970s, Japanese manufacturers, Honda, Yamaha, Kawasaki, and Suzuki, blitzed the market with lightweight, leak-free motorcycles produced in hyper-automated factories using modern computer numerical control machining centers, precise aluminum die casting, and flawless electrical systems. Compared to Japanese precision, AMF-built models looked like agricultural relics. Sales plummeted, and by 1980, Harley-Davidson was sliding rapidly toward bankruptcy. Management took the hint. In 1981, 13 dedicated executives, led by Vaughn Beals and Willie G. Davidson, grandson of co-founder William A. Davidson, staged a dramatic management buyout. Pledging personal assets, home mortgages, and life savings, they bought the company back from AMF for $80 million under the rallying cry, "The eagle soars alone." They overhauled manufacturing, adopting just-in-time inventory control, statistical process control, and investing millions in modern CNC vertical machining centers and Timken tapered roller bearings. Factory teams fought for temporary tariff relief from International Trade Commission to buy time, rebuild their engine platform, and restore quality to their heavy V-twins. This bold effort saved the company from the brink of extinction. Yet the true story of Harley-Davidson is not written in corporate balance sheets, stock market tickers, or boardroom restructuring plans. It is written in the physical permanence of heavy iron. Walk through industrial job shops and precision machine shops across America today, and you will witness a fascinating phenomenon. Long after AMF's corporate raiders faded into history, physical machines created during the golden era are still at work. 80-year-old heavy cast iron lathe beds, hand-scraped ways, and vintage Milwaukee-built machinery, retrofitted with modern digital readouts and computer controls, continue cutting steel components to a 10,000th of an inch. Likewise, thousands of classic Harley-Davidson flatheads, knuckleheads, and panheads built in the 1930s and 40s continue to rumble down highways worldwide. They outlasted the men who forged them and the factory walls that housed them. Think about the resilience of that iron. Modern plastic consumer tech is engineered for planned obsolescence, destined for a landfill in 3 years. But a heavy gray iron crankcase, poured with generous wall thickness and machined with obsessive pride, carries a lifespan measured in centuries. Corporate entities change hands, executives retire, and paper fortunes evaporate. The company died multiple times on paper. The iron did not. If you enjoyed this deep dive into the mechanical grit and industrial history behind America's most iconic motorcycle empire, check out our video on the screen right now, where we explore another forgotten giant of heavy engineering. Until next time, keep your iron sharp.